Hello, and welcome to another Algebra Wizard tutorial video. This is Mr. Sehon, here to talk to you today about rates and unit rates. To understand what a unit rate is, we must first look at what exactly a rate is. A rate is nothing more than a ratio or a comparison of two values that are represented by two different units of measurement. For example, many times we consider the idea of miles per hour as a rate because it's comparing two different measurements, one of distance and one of time. Another one is something like cost per pound. In this case, it's a measurement or a ratio that compares the measurements of value of money compared to something's weight. Many such rates can be made, and rates can be any type of measurement compared to any other different type of measurement. One measurement type you would not actually encounter, however, would be something like miles compared to miles, or miles compared to any other type of distance, unless it's at a constant rate. But miles compared to miles would not be something like 3 miles for every 1 mile. It doesn't really work that way. So that's not really a rate. That's going to be a different type of ratio for some other piece of information that you don't need. Now that you kind of have an introductory understanding of what a rate is, let's talk about what makes something a unit rate. If you'll look at the word unit, as we discussed in class, one of the things that should pop out to you is the prefix un or uni, which simply means one. So anytime you talk about something that's a unit, that means that there is one of something involved. In this case, a unit rate means that it is a comparison to a value of one measurement, or one unit. Remember earlier when I mentioned a common rate is miles per hour? Well, maybe you didn't know this, but miles per hour is actually a unit rate. Because what it is a comparison of some number of miles, say 75, for every 1 hour. So 75 miles per hour means that you're traveling a rate of 75 miles of distance for every 1 hour that passes. We can then take this unit rate and calculate things like, well, how far will I travel if I travel for 3 hours? Because 3 is simply 1 times 3, I would take 75 and multiply it by 3. To keep it as an equivalent rate, and I wind up getting 225 miles. So in this example, the unit rate is the 75 miles per hour because it is a comparison to one unit of measure, whereas the 225 miles in 3 hours is simply a rate because it's just comparing a number of miles to a number of hours, which are two different units of measurement. So let's say I'm asked to find what is called a unit cost, or a unit rate that tells us how much something costs per pound. In this case, it costs $25 to buy 5 pounds of avocados at a store. So I want to know, well, what is the unit cost? When I say the word unit cost, the thing that should remind you that this is for a unit rate is the word unit, which means a comparison to 1. So in this case, I want to compare it to 1 pound, not $1. Because most people don't care about the idea of, well, how many pounds per dollar do I get out of this? But sometimes you can do that. But in this case, unit cost means $25, or how many dollars per 1 pound. So I would, of course, set up a ratio. In this case, the $25 is going to be my cost of money over the number of avocado pounds, so 5. So at a rate of $25 for every 5 pounds, I need to figure out, well, what is the equivalent ratio or rate that would get us 1 pound? Remember that whenever you create equivalent ratios or rates, you're supposed to be able to multiply or divide both of the numbers by the exact same factor. In this case, how would you say that 5 becomes 1? Well, 5 becomes 1 by dividing by 5. So to keep this equivalent, I need to divide the number of dollars by 5 as well. And that gives me a total cost of $5. So the unit rate is $5 per pound. I know this is a unit rate because per pound implies that there is only 1 pound, since pound is written in the singular, and a unit rate is any rate that compares to a value of 1. One thing you might also notice is that when you create a unit rate, you're always going to divide both numbers by the second value here. In this case, I divided both of them by 5. So let's say we have the following rates. This could be 64 miles for every 8 hours, 64 inches per 8 seconds, 64 words typed in 8 minutes. It doesn't really matter exactly what the rate is, but you can still treat all rates the same way because they're all in essence just ratios. Remember that earlier we were talking about how unit rates have to be a comparison to 1, so somehow I have to be able to change this to a rate compared to 1. If you remember from the previous example, one thing that you could do is just simply take the top number of a ratio and divide it by the bottom number. And that should give you the unit rate. In this case, 64 divided by 8, I know, equals 8. So whatever the measurements are, 64 miles, 64 inches, $64, or 8 minutes, 8 seconds, 8 whatever, the unit rate has to be 8 of whatever to 1 of whatever you have. Because 64 divided by 8 creates the equivalent rate of 8 to 1. Again, I know this is a unit rate because unit rates always compare to a value of 1, and this does compare to a value of 1. But what if you encounter a rate like 28 over 4, or 28 somethings to 4 somethings? Well, in this case, I know that I need to divide both of these by 4, because the second number is a 4. And to make 4 1, you have to divide it by 4. Well, that's going to equal 1, but then 28 and 4, they divide to make 7. Oh, wait, never mind. This worked out just fine. This was not an example I was thinking of. Oops, sorry. Let's say that we had a rate like this. Let's say we have a rate of 12 somethings to 8 somethings. In this case, if I divide both of them by the bottom number of 8, I know 8 divided by 8 comes out to 1, but 12 divided by 8 does not come out to a rounded whole number. So this is the case when I have to create either a fraction or a decimal. We have not gone over in class how to exactly divide out to fractions or decimals, but I can show you that pretty quickly. If I take 12 and I divide it by 8, I know 8 goes into 12 one time. 1 times 8 gives us 8. 12 minus 8 gives us 4. Here are your two options. One way you could go is you could simply say that it is 1 remainder 4, but rather than leaving it as a remainder, you have to take your original divisor of 8 and make it your denominator. What this does is it creates a fraction, or a mixed number rather, of 1 and 4/8. 1 and 4/8 simplifies to 1 1/2, so you know that the rate, the unit rate, has to be 1 1/2 to 1, or 1 1/2 somethings for every 1 something. If that way confuses you, however, I would suggest going the other way. Rather than continuing, or rather than saying a remainder, what I'd end up doing is taking a decimal value, making a decimal value out of the 12, which means adding a decimal point followed by a 0. The decimal point in the answer matches what's inside of the dividing symbol, and so then I have something to drop and continue dividing. Well, 0 drops down here to create 40. So I figure 8 into 40 is 5 times. 5 times 8 is 40. Subtract, and I get a remainder of 0. Once I reach 0, I don't need to continue dropping any further, so that means that I have an answer of 1.5, or 1 5/10, which is equivalent to 1 1/2, which is the answer we had earlier. So I know that the rate is also, the unit rate, is 1.5 for every 1. So 1.5 somethings for every 1 something is our unit rate in the case of 12 somethings to 8 somethings. I hope that you have found this video helpful in being able to figure out how to work with rates and unit rate in math. Thank you very much, and have a great time exploring the world of math. I look forward to seeing you in class again. Have a great day.